All right. Empirical formulas are formulas which have been reduced to their lowest possible terms. Okay. So basically, what an empirical formula is we talked about percent composition the other day. Okay. And if I was to have this unknown compound, I could figure out its percent composition by burning it and figuring out how much carbon and hydrogen there are. And I could take that percent composition and I could figure out what is its lowest possible formula. Okay? And it's not necessarily the actual formula of what it is, but it's the lowest common one that it can be. Okay? And so, for instance, if I had this compound C6H6, I could reduce that to its empirical formula. Okay? So how could I reduce that? What would be the common lowest ratio I could have of C6H6? CH. So CH would be its empirical formula. I need a darker color, don't I? Okay? So CH would be its lowest possible formula. If I had this one, C2H5, could I reduce that?
No.
No, so it would actually be its empirical formula already because it's already at its lowest, okay? And so sometimes when we're doing these, when we're doing molecular formulas, you might be given the empirical formula or you might have to calculate the empirical formula, okay? So let's talk about how we're going to do that, okay? This is a lot of steps, okay, that you can read through and follow. But you're going to take the grams if you're given grams and you're going to divide by the number of the molar mass to get to moles. So you got to convert everything to moles, okay? If you're given a percentage, okay, we're going to assume 100 grams because if I'm giving you that something is 15% carbon and I assume 100 grams, how many grams of carbon would I have? 15. So if you're given a percentage, you always assume 100 grams, okay? So I could read through all this and you're going to be like, what the heck is she doing? It's just better to show you and then you go back and read the steps if you don't understand what we did, okay? So I'm going to show you. It's really not that hard, okay? Just that makes it look like it's hard, doesn't it? Faith is looking at me like, what is she doing to us today? Okay? So, we have this example here. These are actually your left side examples, I believe, okay? So I'm going to leave those to do that. I'm going to actually do my own example to show you very simply. And so if you will, that little space under number 5, you can write that example there. Okay, so we are going to have an example, and we're going to say that we have 85.6% carbon, and we have 14.4% hydrogen. So we went into the lab, we combusted it, and this is what we found. Okay, and so now we want to find out what's the empirical formula, meaning what's the simplest ratio that this compound could be. Okay, so our first step was to assume 100 grams. So if I assume 100 grams, that means I have 85.6 grams of carbon, and I have 14.4 grams of hydrogen. Let me write this up there. We assumed 100 grams. All right, so once we assume that, our next step is we need to convert both things to moles. Okay, we need to convert both things to moles. How do I convert from grams to moles? We just did it on the worksheet from the weekend. We'll use our little grid, and we're going to use our what? Molar mass. So we're going to set up our grid for carbon. If we look up on the periodic table, the molar mass of carbon to 2 decimal places is 12.01 grams of carbon per 1 mole of carbon. So someone do that math. We're going to want to put this in about 4 decimal places. Okay, 4 sig figs, 4 decimal places. We got to go. Sometimes you have to go out kind of far to make sure that we get good numbers.
7.137.
Give me more decimal places than that. Give me 4.
7.127.
Okay. So now we are going to do the same thing with hydrogen. We're going to convert it to moles. So what is the molar mass of hydrogen? It's on the table. 1.01 grams of hydrogen over 1 mole of hydrogen. Okay, so now our grams have canceled on everything. So take that one out to 4 decimal places, please.
14.2574.
14.2574 moles of hydrogen. Okay, so now that we're in moles, we can compare them. And here's the next step. Okay, I'm going to change colors just so you can see that it's a second step. Now our next step is to divide both of them by the smallest number of moles. Okay, in this case, the smallest number of moles is the carbon, right? So we're going to divide both of them by 7.174, 7.1274. Okay, so clearly this one's going to be 1. Okay, and then if you do that one, what do you get? I mean, I'm going to tell you it's 2. 2. Okay? Now, that is our formula. That means that we have, our empirical formula is 1 carbon and 2 H's.
So it's CH2.
So it's CH2. Now, the way that I have you designate that we know that this is an empirical formula, not a molecular formula, is we're going to do this. We're going to put parentheses around it, and we're going to put a little N right there. And that's going to say that's an empirical formula. If you didn't put that around there, I'm not going to count it wrong, but you'll see that that helps us realize that when we go to the next thing, how to do molecular formula. When we do molecular formula, we're going to calculate that N to figure it out. Now, I would look at this and know that this can't be a molecular formula because you can't just have 1 carbon and 2 hydrogens. You don't have enough bonds. So I would look at that and say that. But as we get more complicated empirical formulas, you wouldn't be able to look at it and tell that. Okay? All right. So I am going to do, I'm actually going to go ahead and do the at least one of the examples of empirical formula. And I'm going to need a calculator for sure. I don't know if I have that one worked on the old notebook or not. Okay. I'll go back. So this is the example in your left side. Because I need to show you a trick, although I don't think it'll show up in y'all's, that y'all need to be aware of it. So we're going to do the example of the 100-gram compound contains carbon, hydrogen, oxygen, and nitrogen. Okay, we're going to do that one. Okay, so first thing we have to do is convert them all to moles. Okay, so we'll start with the carbon first, 22.430 grams of carbon, divided by its molar mass, and we get 1.8676 moles. Then we'll do hydrogen. So hopefully y'all are doing this with me. Divide by its molar mass, 1.01. Are y'all starting to get some of these memorized from using them so often? Then we'll do, what's next? Nitrogen? Oxygen.
Oxygen.
44.8598 grams of oxygen. Oxygen's in a compound here, so it is 16. It's not diatomic when it's in a compound. So it would just be 16. And we get 2.8037 moles. And then nitrogen is last, 26.1682 grams of nitrogen. And again, not diatomic when it's in a compound, so we just use the 14.01. Okay, so next step is to divide by the smallest, right? So which one is the smallest? First one. So we know that one's going to be 1, and we know that one's going to be 1. Okay? If we do the next one, we get 3.5. And on this one, we get 1.5. And that's a problem. Can I have 3.5 atoms? No, I cannot. Okay? So that's a problem right there. So what we have to do, and this kind of confuses some people sometimes, is we have to take an integer and multiply them all by an integer that would make them be a whole number. Okay? So in this case, what integer could I multiply by to get it to be a whole number? 2. So I'm going to multiply everything by 2, because what I do to 1, I got to do to all of them. Okay? So I'm going to say times 2, times 2, times 2, times 2. This is a good time where using color for you guys would be helpful, so when you go back and look at it, you know the order that you did things. Okay? So then this is 2, this is 7, this is 3, and this is 2. So now I can do my empirical formula of C2, H7, O3, N2. Okay? Any questions at that point? Most of the time, like on your worksheets today, they'll be whole numbers. In case one was to show up, I need to show you that because that's kind of important. Okay? So that's the hard part. The molecular, figuring out molecular is actually much easier. Okay? It's actually much, much easier. I promise. Okay? It won't be there. Once I go away, it goes away. It will be on the notes, though. If you need to go back and look at it on the notes, it will be there. But once I click off of there, I can't. It doesn't show back up, unfortunately. So molecular formulas are either going to be the same as the empirical formula, or they're going to be a higher whole number ratio above. Okay. So here's the way you're going to calculate molecular formulas. Okay. I'm going to tell you how to solve for that n. Remember how we put that little n on the outside? I'm going to tell you what n is equal to. N is equal to, so you need to write this down somewhere, okay? It's going to be equal to the molar mass. Back up. Divided by the empirical mass. Okay? The molar mass will be given to you in a problem. The molar mass is determined experimentally when they're finding out a new compound. Okay? The empirical mass is the mass of what you found the empirical formula to be. It's calculated the same way. Okay? So a while ago we found that empirical formula to be CH2. Okay? So to find its empirical mass, we would take a carbon plus 2 hydrogens. So it would be 12.01 plus 2.02, so it'd be a total of 14.03. It's calculated the same way as a molar mass, it's just the mass of the empirical formula. Okay? So, we're going to do this same, we'll go and do one of those examples, but I'm going to do, so you can do it down at the bottom of that page, where that little space is. Earlier we found okay, so it's still up there. Earlier we found CH2 to be our empirical formula, right? So if given molar mass is equal to 42.09 grams per mole, now we want to find molecular formula. Okay, so we're going to do this little equation right there. N, so they gave us the molar mass, right? So that always goes on top. Here's a hint. A bigger number will always be on top. Either the same or bigger number always on top. Okay? And we're going to divide by the empirical mass, which is the mass of this. Add it up the same way, it's just empirical mass because we don't know if that's the final formula. So we just did that. We did 12.01 plus 2 times 1.01, which was 14.03, right? So divide by 14.03. And what does that come out to be?
3.
3. So now we take this 3 and we substitute it in for that n. And remember, if you got something on the outside, you multiply everything on the inside. So the molecular formula would be what?
C3H6.
C3H6, and that's how you do that. So that part, say what?
Never mind.
Did you answer your own question?
Well, wouldn't it be CH2 then?
No,
Wait.
empirical formula is
Okay,
CH2.
Okay, yeah.
Okay, so the empirical formula is CH2, like this, I wrote over it, okay?
Yeah.
So that's the simplest thing it can be, but its actual real formula, like what it
Yeah.
really is C3H6,
Alright.
okay? Now, if we had gotten a compound that had a higher molar mass, that compound could have been, you know, if you had ended up being equal to 4, you would have C4H8. I mean, it just depends, because if you think about it, if I have several compounds, their percent composition would be the same. So that's why the empirical formula is the simplest. Because whether I have C6H6 or C2H2, they could all be reduced to an empirical formula of CH.
Okay,
So if I went into the lab to figure out the percent composition of those two compounds, their percent composition would come back the same. Because the percentage of carbon would be the same, and the percentage of hydrogen would be the same. However, they are not the same compound. C6H6 is benzene. Okay, it's a solvent. It's also carcinogen. C2H2 is ethine. I mean, not ethine. It's ethine. Yeah, it's got a triple bond. It's completely different. But their percent composition would be the same because they have the same empirical formula. But the molecular formula is its true formula.
Okay.
Okay?
Alright.
Does that seem pretty straightforward?
Yeah.
Now, okay, so that is where we're going to stop, okay? Because I want you to have time to work on the worksheet.